Bismillahirrahmanirrahim. Assalamu alaikum. And the topic we will discuss today is the system with the gears. Actually, this is also the part of mechanical system. We have already done with the system, mechanical system, having translational mechanical system and the rotational mechanical system. Actually, the system with gears is also the part of rotational mechanical system. The gear system with gears, basically, if we talk practically, then all the motors are rarely seen without associated gear train driving the load. Actually, the gears are used to drive a load, and we transfer load, we apply torque on one side of the gear, and we will uplift the load, or we drive the other gear on the other side. The examples of system with gear are your bicycle, your bike, your vehicle you drive. अगर हम बात करें इसमें बाईसाइकिल की, माउंटेन बाइक की, तो जो चलाते हैं माउंटेन बाइक, सिंपल है कि जब भी हमने किसी हिली एरिया पे जाना होता है, चढ़ाई पे चढ़ना होता है, तो हम गियर चेंज करते हैं, क्योंकि जब हमने जब क्लाइंब करते हैं किस जगह पे, तो वी नीड मोर टॉर्क एंड लेस स्पीड. We are concerned that we apply more torque, and speed is always less, and we will when we drive on the straight road, we need more speed and less torque. The simple diagrams of the system with gears. In this, the input gear is the smaller and the output gear is the larger one. This is also the example of system with gear. This is also the example of system with gear. Okay, let we start our topic. Actually, we are considering the ideal gear. This is our input gear. The input gear has radius R1, and the number of teeth on the input gear is N1, and the torque applied on the input gear is T1, while the angular displacement covered by this input gear is theta 1. And by applying torque, we will move this gear 1, and the effect of this will also move the second gear, or we can say this is the output gear, output driven gear. And the input torque on the output torque will be the T2, and the number of teeth on the second gear is N2, and the radius of the second gear is R2, and the angular displacement by the second gear is the theta 2. We also must know the term backlash. Actually, these both gears are connected through their teeth, and if we stop applying the torque on gear 1, then it will stop, but the gear 2 is still in motion, and it will stop, and it will give you the backlash, means it will move back. This is this happens in practically, but we are considering the ideal gears. Now we will find the equations for the input torque, output torque, input angular displacement, output angular displacement, and the number of teeth on the input gear and the output gear. Here we can see the distance traveled along each gear. Circumference will be the same, so the R1, radius of input gear, into the angular displacement of input gear will be equal to the radius of output gear and the angular displacement by the output gear. Actually, the ratio of the number of teeth along the circumference is in the same proportion as the ratio of the radii. As you know that it's if this is the this gear is small in radius, it has less number of teeth. and if this gear is higher radius or greater radius, it should have the greater number of teeth. So you can say that the radius is directly proportional to the number of teeth. Same is written here. The ratio between the R1 and R2 will be equal to the N1 by N2. This is the relation between the radius of the gears and the number of teeth on the gears. Okay, now if we find the relation of angular displacement by the output gear with due to the input gear, you can say theta 1 from this relation. From this relation written here, we can write theta 1 by theta 2 will be equal to the R2 by R1, or we can also write as R1 by R2 is equal to N1 by N2. So R2 by R1 will be equal to by N2 by N1. So theta 1 by theta 2 will be equal to the N2 by N1. Means angular displacement is inversely proportional to the number of teeth, right? I will repeat again. The radius is directly proportional to the number of teeth on the gear, but the angular displacement is the inversely proportional to the number of teeth of the gear. So if we find the angular displacement of the output gear, we can write that angular displacement with the output gear should be equal to the number of teeth on the input gear by number of teeth on the output gear multiplied by the angular displacement of the input gear. Here the input energy is the actually what is the energy? Energy is the force into the angular displacement. So we can write energy in the translation system is force times displacement. We can say energy in translational system is force times displacement. So here also the energy will be equal to the force applied and the angular displacement by the input gear, and the output energy will be equal to the output torque and the angular displacement, output angular displacement. So for lossless gears, in which you can say the ideal gears, you can write T1 theta 1 will be equal to T2 into theta 2. So the relation between the torque and the angular displacement and the number of teeth is written here. Means if the higher torque, less angular displacement and less number of teeth, means the torque is inversely proportional to the directly proportional to the number of teeth. Means if we have higher torque, T1 is torque is directly proportional to the number of teeth and inversely proportional to the angular displacement. You can say if we have smaller gear and this one is the bigger gear, if this gear rotates 3 times, means it will travel 3 circles, or it will complete its 3 rounds. Then the larger gear will complete its 1 round. So higher the number of teeth, less will be the angular displacement, and the less number of teeth will yield the larger angular displacement. Clear? So you should familiar about these relations: the relation of the angular displacement, the angular displacement and the number of teeth, and the number of teeth and the radius of the this gear system. So by using this concept, we will solve our gear system. Here, mathematical model of ideal gears. Let's suppose we have this input gear and we have this output gear. We can draw its block diagram like theta 1 is the angular displacement of the input gear and theta 2 is the output angular displacement of the output gear. And as we have already know, the relation between theta 1 and theta 2 is equal to N2 by N1. And what will be the value of theta 2? Theta 2 will be equal to the N1 by N2 into theta 1. So we can write N1 by N2 into theta 1. Means theta 2 will be equal to the theta 1 into N1 by N2. And what will be the value of output torque? As we know that the torque is directly proportional to the number of teeth on the gear. So the theta 2 will be equal to n2 by n1 into t1. Now we have this example, transfer functional system with gear. This is the input shaft. Actually, this is the shaft. We have applied the torque here, and it moves the angle theta 1, and n1 is the number of teeth. Basically, it's a gear. This is the input gear, and this one is your output gear. We have just shown it with the straight line, and we have written n1 is the number of teeth on the input gear, and n2 is the number of teeth on the output gear. And by applying torque on this, the load, here is the load on the output shaft. It has one inertia or one damper, one spring, and by applying torque here, by the force is transferred with the help of gear, and the torque on this, the torque on the output shaft will be, the torque on the second gear or output shaft will be T2 is equal to N2 by N1 into T1, as we have already shown here that by this diagram, T1 is the input torque and output, T2 is the output torque, and N2 by N1 will be the ratio of teeth ratio, gear teeth ratio, this by this relation. By using this relation, T1 by T2 is equal to theta 2 by theta 1 equal to the N1 by N2. As we have seen that theta 1 angular displacement is inversely proportional to the number of teeth. So as torque is also proportional to the number of teeth, so that inversely proportional to the angular displacement, and so torque is directly proportional to the number of teeth. So here it comes T2 equal to N2 by N1 into T1. So we modify this diagram in this form. Actually, we transferred this torque to the output, this input torque to the output shaft, output rod or output. It appears here when the input gear move clockwise, the output gear will move in the opposite direction, in the anti-clockwise direction. Right? Look at this picture. The one gear is moving in the clockwise direction, and the output, this is the input, it's moving in the clockwise direction, and the output is moving in the anti-clockwise direction. Right? So the direction is shown here. It's moving in the clockwise direction, and output torque will be moving in the output anti-clockwise direction. So we transferred, or you can say it's the output after reflection of the input torque. Okay, we reflected this torque on the output torque. Now you can write the equation, and as we have already studied that the number of equation depend upon the number degree of freedom, and this system has only 1 degree of freedom. Okay, the gears are eliminated by finding the equivalent torque after gears. So we can write applied force. What is the applied force here? It is the reflected torque at the output. This one is the input force, and what are the impedances? This is the this inertia and damper and the spring, and we write the equation this. But you know very well that theta 2 is equal to n1 by n2 into theta 1 from this block diagram, or from this relation, that theta 1 by theta 2 is equal to n2 by n1, as the angular displacement is inversely proportional to the number of teeth. So theta 2 is equal to n1 by n2 into theta 1. So we will put this here, that theta 2 is equal to n1 by n2 into theta 1. So we will replace theta 2 by this, and now we will multiply this n1 by n2 square by all the impedances, and theta 1 will be common, equal to t1, and this is our reflected load with reflected at output. The transfer function of the system with gears. This was our equivalent diagram, and we redraw it here that T1 is applied on the output and theta 1 is the by this equation. By this equation we draw actually after transferring load or torque from input input torque to the output, we draw this diagram, and by solving this equation we can redraw it again in this form. T1 is the input torque, direction of T1 will be the same, and theta 1 is the angular displacement, and we replace over all the impedances as we have solved it, and we will put replace J by J, N1 by N2 square, and D into N1 by N2 whole square, and so on. Okay, now it's very important that if we want to reflect torque from input side to output side, and if we want to reflect the impedances, then this will be the equivalent diagram. This is the equivalent system at the output after reflection of input torque. Okay, and this is the equivalent system at the input after reflection of impedances. These are the similar diagram as we have seen in the last slide. Okay, let's we try an example. This example is the example number 2.21, I think, of your book. Okay, before starting an example, you should know if we want to shift impedances. Actually, here you can see there are impedances attached with the input as well, and impedances at the output are there as well. So first we have to transfer impedances from input side to the output side, then we will transfer torque from input side to the output side, and then we will solve our system. So we will transfer impedances before the gear must be reflected to the network after the gear. Okay, now note down that if we want to reflect the impedances through gear trains by multiplying the mechanical impedances, how can we transfer this impedance D1 on the load side? Then it's what we will do. Actually, जब भी हम कोई इम्पीडेंस ट्रांसफ़र करेंगे फ्रॉम इनपुट साइड टू द आउटपुट साइड, हम क्या करेंगे, वी विल मल्टीप्लाई number of teeth of gear on destination shaft by number of teeth of gear on the source shaft, and we will take whole square. Clear? And what will be the output? The transfer function theta 2 by T1 for the given system. It means we are taking output at the theta 2. So we will multiply theta, the number of teeth on the destination shaft. What is destination? Here is destination is the N2. So हम मल्टीप्लाई कर देंगे N2 by N1 into का whole square with the D1. So if we want to reflect D1 on the load side or या output side, how can we transfer? कि हम उसको डायरेक्ट D1 को यहाँ D1 ही ट्रांसफ़र नहीं करेंगे. हम जब D1 को ट्रांसफ़र करेंगे it will become N2 by N1 square into D1. Similarly, जब हम inertia को ट्रांसफ़र करेंगे from input side to the output side, it will become N2. Basically N2 is the number of teeth on the destination shaft by N1 number of teeth on the source shaft square into J1. It will become this. Okay, impedances of the same time will be added. Means कि जब हम J equivalent लिखेंगे, J equivalent क्या होगा? J equivalent will be equal to the J1 plus J2. J2 तो हमारा आउटपुट साइड पे ही है, लोड साइड पे ही है, तो हम J2 तो शिफ्ट नहीं हुआ, हमारा J1 शिफ्ट हुआ है. जब J1 को हमने शिफ्ट किया तो J1 को हम क्या लिखेंगे? J1 विल बी इक्वल टू J1 मल्टीप्लाइड बाय नंबर ऑफ टीथ ऑन द डेस्टिनेशन शाफ्ट बाय नंबर ऑफ टीथ ऑन द सोर्स शाफ्ट का स्क्वायर प्लस J2 आ जाएगा. सिमिलरली जो K इक्विवेलेंट होगा, व्हाट विल बी द K इक्विवेलेंट? K इक्विवेलेंट विल बी इक्वल टू द K2 as there is no K1 or any spring on the सोर्स साइड। और डी इक्वलेंट, डैम्पर इक्वलेंट क्या होगा कि D2 it's not shifted on anywhere, this D1 is shifted here, so D equivalent will be equal to the D1, and D1 will be multiplied by the number of teeth on the destination shaft by the number of teeth of gear on the source shaft square plus D2. Clear? I hope it will be clear. Now this will be the equivalent diagram. Now look at this, it's moving in clockwise and the source will be moving in the anti-clockwise direction. We also shift the torque as we have done in the last example, and we know very well. I will show again the slide from this slide, or from this T1 by T2 is equal to N1 by N2, and what will be the value of T2? T2 will be equal to T1 multiplied by N2 by N1, and same we have written here, T2 is equal to N2 by N1 in okay, multiplied by T1. Okay, this is theta 2, and we have written here the equivalent impedances. This is the damper equivalent, this is the spring equivalent, this is the inertia equivalent, and again we will write the equation of motion. This is the applied force, and will be equal to the number of impedances multiplied by the angular displacement. These are the J equivalent, S square, assets in second order. We have written it's in frequency domain, and it's the damper equivalent, and this is the spring equivalent, or it's equal to the K2, and the ratio of the output angular displacement by the torque will be equal to, we can find from this equation that this will be equal to the N2 by N1 divided by all the impedances. Clear? Now our next example or next concept is the gear train. What is the purpose of gear train? Actually, in order to eliminate gear with large radii, a gear train is used to implement large gear ratio by cascading small gear ratios. Means if we have a system that has the large gear, to eliminate the large gear from the system, we cascade small gears, and this is called a gear train. We use the gear train, and we by using this gear train we will get the same result as by using the large radii gear. Okay, or a large radius gear is not available, or you want to design with a small radius gear, you can use the gear train. Now what will be the effect of theta 1 and on the theta 3 or output angular displacement? It's here it's theta 1, theta 2, theta 3 and theta 4. Look at the directions, it's clockwise, it's anti-clockwise, again then clockwise, it's again in the anti-clockwise direction. Okay, what will the theta 2? Theta 2, as we have written earlier, theta 2 is equal to N2 by N1 into theta 1. As by, again I will show you the first slide, this one, yeah, this one, theta 1 by theta 2 is equal to N2 by N1, and theta 2 is equal to N1 by N2 into theta 1, N1 by N2 into theta 1, yeah, this N1 by N2 by theta 1. And what will be the value of, actually you can say that theta 1 is equal to the number of teeth on the source shaft by, actually when we will transfer, don't make mistake, इसको आप बड़ा गौर से समझ लें कि जब हम इम्पीडेंसेस को ट्रांसफ़र करते हैं फ्रॉम लोड टू डेस्टिनेशन साइड, तो हम क्या मल्टीप्लाई करते हैं कि नंबर ऑफ टीथ ऑन द डेस्टिनेशन साइड बाय नंबर ऑफ टीथ ऑन द सोर्स साइड का स्क्वायर। और जब हम एंगुलर डिस्प्लेसमेंट को रिफ्लेक्ट कर रहे हैं फ्रॉम सोर्स टू डेस्टिनेशन, then we will multiply by number of teeth on the source by number of teeth on the destination, and it will not scale, हम उसको scale नहीं करेंगे, ठीक है। and what will the theta 3? theta 3 का क्या? theta 3 का destination क्या है? n3 है, source क्या है? n4 है, into theta 2 है। और थीटा 2 की वैल्यू क्या थी, n1 by n2. We will put the value of theta 2 and it will become theta 2 is equal to n1 by n3 by n2 n4 and now what will be the value of theta 4? Theta 4 will be the equal to the what is the source for theta 4? Source teeth is n5 and destination teeth is n6, n5 by n6 into theta 3. And what is the value of theta 3? We have already find the value of theta 3. We will put it, and now you can see that by using the gear train, the angular displacement is reflected at the output. Theta 4 is equal to the number of teeth at n1, n3, n4, n5 by n2, n4, n6 into theta 1. Clear that output angular displacement is written in terms of input angular displacement. Similarly, if we have more number of gear trains, then simply you can write the odd number of teeth on the top and even number of teeth at the bottom, and multiply by it will be multiplied with the theta 1 input angular displacement. Here is the block diagram of the above given system. Theta 1 is the input angular displacement. This is the system 1 G1. This is the transfer function of system 2. This is the transfer function of system 3, and this is the output angular displacement, or you can say our theta 4. Okay, now we will solve another example, which is the example of the system with gear train. In this we have to find the theta 1 by t1. It means we have to transfer all the impedances from load to source side. इससे पहले हम क्या करते रहे कि तमाम impedances को हम ट्रांसफर करते हैं फ्रॉम सोर्स टू लोड साइड. अब हम ट्रांसफर करेंगे किस साइड पे हम ट्रांसफर करेंगे कि एक्चुअली हम आउटपुट भी हम कहाँ ले रहे हैं, थीटा 1 पे ही ले रहे हैं. आउटपुट हम इधर ले रहे हैं. जितने भी ये हमारे पास impedances हैं, this is the J5, this is J4, J3, J2, D2, D1, J1. ये तमाम impedances कहाँ रिफ्लेक्ट होंगे, फ्रॉम लोड टू सोर्स साइड. और मैंने उसका आपको मेथड क्या बताया था कि जब भी हम किसी इम्पीडेंस को ट्रांसफ़र करते हैं फ्रॉम वन प्लेस टू अनदर, we'll multiply this by number of teeth at the destination shaft, destination gear by number of teeth at the source gear का स्क्वायर ले लेते हैं. अब you can see this equation. What is the J equivalent? J equivalent equal to J1 as it's connected with the source gear, so it will not be multiplied with any teeth. Now what will the J2 and J3? We will shift this J2 and J3 will be reflected at the, actually we have to reflect this load at the source end. So क्या करेंगे, हम इसको मल्टीप्लाई कर देंगे with the number of teeth with the number of teeth at the destination gear. destination gear अब क्या है हमारा, N2 नहीं, अब N1 है, और source gear हमारे पास क्या है, N2 है. तो हमने क्या कहते हैं N1 by N2 स्क्वायर प्लस अब हमने इसको भी शिफ्ट करना है, J4 एंड J5 को भी शिफ्ट करना है, J4 एंड J5 को भी हमने शिफ्ट करना है. तो J4 और J5 के लिए मेरे पास क्या हो जाएगा, नंबर ऑफ टीथ एट डेस्टिनेशन क्या है, इसकी डेस्टिनेशन क्या है J3, इसकी डेस्टिनेशन क्या है N3 है, और सोर्स क्या है मेरे पास इसका N4 है. तो N3 by N4, फिर यहाँ से दोबारा शिफ्ट होंगे कहाँ पर, थीटा इस पे, तो इसको फिर दोबारा कर देंगे. इसका डेस्टिनेशन अब क्या है N1 और सोर्स क्या है N2. तो क्या आ जाएगा N1 N3, these both will be the destination gears एंड और मेरे पास सोर्स गियर्स क्या है N2 और N4, इसका स्क्वायर आ जाएगा. सिमिलरली जब मैं D डैम्पर को शिफ्ट करूँगा, रिफ्लेक्ट करूँगा फ्रॉम, बेसिकली मैं यहाँ क्या देख रहा हूँ, रिफ्लेक्टेड लोड देख रहा हूँ. एक्चुअली में शिफ्ट नहीं हो रही है, हम रिफ्लेक्ट कर रहे हैं कि आउटपुट पे या इनपुट पे क्या असर होगा इनका. तो क्या होगा मेरे पास, डी इक्वल मेरे पास क्या हो जाएगा, D1 ये कनेक्टेड है ऑलरेडी विद द इनपुट गियर, और D2 को जब मैं रिफ्लेक्ट करूँगा, D2 को जब मैं रिफ्लेक्ट करूँगा फ्रॉम दिस गियर टू द गियर हैविंग नंबर ऑफ टीथ N1, व्हाट विल बी द, व्हाट विल आई डू कि मैं इसको मल्टीप्लाई कर दूंगा D2 को विद द नंबर ऑफ टीथ एट डेस्टिनेशन गियर बाय डिवाइडेड बाय नंबर ऑफ टीथ एट द सोर्स गियर N2 का स्क्वायर आएगा. क्लियर. नाउ ऑल द इम्पिडेंसेस इनर्शिया एंड डैम्पर, इसमें दो ही टाइप की इम्पीडेंसेस थी, स्प्रिंग नहीं था इसके अंदर। तो जब ये दोनों इम्पीडेंसेस शिफ्ट हो गई जे इक्विवेलेंट एंड डी इक्विवेलेंट, नाउ वी कैन इजीली फाइंड द ट्रांसफर फंक्शन थीटा वन बाय टी वन। ये हम इसको लिख सकते हैं, दिस इज द जे इक्विवेलेंट, दिस इज डी इक्विवेलेंट, जे इक्विवेलेंट इंटू डी इक्विवेलेंट इंटू थीटा वन इज इक्वल टू द टी वन। व्हाट इज द टी वन? टी वन इज द अप्लाइड टार्क। जबकि हमने मालूम किया कि जे इक्विवेलेंट मेरे पास किसके बराबर है, ये है, अभी हमने लास्ट मालूम किया, और डी इक्विवेलेंट मेरे पास इसके बराबर है। तो ट्रांसफर फंक्शन मेरे पास किसके बराबर आ जाएगा? ट्रांसफर फंक्शन जी ऑफ एस इज इक्वल टू द थीटा वन बाय टी वन, एंड दैट विल बी इक्वल टू द वन ओवर जे इक्विवेलेंट by d equivalent. From this equation theta 1 by t1 equal to the 1 over j equivalent s square plus d equivalent s square। क्लियर है? तो बेसिकली इसमें कि हमने लोड को ट्रांसफ़र करना है, रिफ्लेक्ट करना है, जिस जहाँ हमने आउटपुट लेनी है। इसकी बहुत से एग्जांपल मैं आपको दे चुका हूँ। बेसिकली गियर सिस्टम किसी भी लोड को रिफ्लेक्ट कर रहा होता है। जैसे अगर आपकी आम से आपको मिसाल दूँ कि अगर आपने अक्सर देखा होगा जो ट्रांसफार्मर जो चेन पुली सिस्टम के थ्रू ट्रांसफार्मर उठा रहे होते हैं, अगर ट्रांसफार्मर को वैसे हम प्लेस करें उठा के, तो कितने नंबर ऑफ पर्सन हमें चाहिए होंगे टू प्लेस द ट्रांसफार्मर फ्रॉम ग्राउंड टू द प्लेस। जबकि हम चेन पुली सिस्टम से क्या करते हैं कि चेन पुली सिस्टम में गियर ही हो रहे होते हैं कि बेसिकली वो जो लोड है वो लोड ट्रांसफार्मर का कम नहीं होता, लेकिन जब रिफ्लेक्टेड लोड होता है, आता है इनपुट के ऊपर, तो रिफ्लेक्टेड लोड वो बहुत मिनिमम हो जाता है कि हमें एफर्ट कि हम उसी चेन पुली सिस्टम से जब हम उसको खींच रहे होते हैं तो रिफ्लेक्टेड लोड इतना नहीं होता। एक ही जो बंदा है वो चेन पुली सिस्टम के थ्रू उसको उठा के ट्रांसफार्मर को हाइट पे ले जाता है। तो बेसिकली गियर सिस्टम इसीलिए यूज़ होता है कि हम जब लोड हमने रिफ्लेक्टेड लोड कम करना, जैसे अगर आपको मैं गाड़ी की मिसाल दूं, जो आप कार ड्राइव कर रहे होते हैं, तो जब आप गियर चेंज करते हैं तो गियर चेंज में क्या हो रहा होता है कि जो आपका इंजन है वो लोड को रिफ्लेक्ट कर रहा होता है। लेट्स सपोज अगर आपका इंजन अगर रोटेट करता है 1000 टाइम्स, आई एम गिविंग एन एग्जांपल, तो आपका व्हील जो है उस पर लोड जो है वो कम शोर होगा, तो व्हील रिफ्लेक्ट करेगी 100 टाइम्स। तो बेसिकली गियर सिस्टम यही कर रहा होता है कि लोड को रिफ्लेक्ट कर रहा होता है फ्रॉम इनपुट टू आउटपुट और आउटपुट टू इनपुट, डिपेंड अपॉन योर रिक्वायरमेंट, क्या आउटपुट या इनपुट पर लोड कैसा रिफ्लेक्ट करना चाह रहे हैं, कम करना चाह रहे हैं, ज़्यादा करना चाह रहे हैं, उसके अकॉर्डिंग आप गियर्स जो है वो डिज़ाइन करते हैं, उसके अकॉर्डिंग लोड को हम रिफ्लेक्ट करवा रहे होते हैं। होपफुली आपको आज का लेक्चर समझ आ गया होगा। इसमें फिर भी अगर कोई क्वेरी है, कोई इशू है जो आपको समझ नहीं आया, then you can ask me question, or we will discuss in the class or in the our online session. Thank you for coming and listen my lecture. Inshallah see you in the next lecture. Take care. Allah Hafiz.